chemical. It's just war. You can't fool me. It's not a chemical.
Understanding chemicals, water, and the human body. A deep dive. When we talk about chemicals, people often imagine lab-coated scientists mixing strange substances or even dangerous compounds. However, the truth is far simpler and more universal. Everything around us is made of chemicals, including our own bodies. From the air we breathe to the water we drink, from the food we eat to the very cells that make up our skin, chemicals are everywhere. But what exactly is a chemical, and how do we classify them? Is water a chemical? Is everything artificial a chemical? Let's break it down in detail. 1. What is a chemical? In chemistry, a chemical is defined as any substance with a specific composition and structure. This can be a simple molecule like oxygen, O2, or hydrogen, H2, or a complex compound like proteins, DNA, or even synthetic polymers. The key is that a chemical has a consistent molecular structure, meaning it can be identified, measured, and studied scientifically. For example, table salt has a chemical name, sodium chloride NaCl. Its structure is precise, 1 sodium atom for every chlorine atom. Similarly, sugar is a chemical known as sucrose, CHO, a compound of carbon, hydrogen, and oxygen in a fixed ratio. Chemicals are not inherently dangerous or artificial. People often associate the term chemical with toxic substances, pesticides, or lab experiments. But in reality, all matter is chemical in nature. Air, water, soil, and even the human body are composed entirely of chemicals. The label chemical does not imply risk. It simply identifies a substance in scientific terms. 2. Dihydrogen monoxide. A classic example, one of the most famous examples that illustrate the misconception about chemicals, is dihydrogen monoxide, a term that sounds intimidating to someone unfamiliar with chemistry. The name dihydrogen monoxide simply describes water, H2O, 2 hydrogen atoms bonded to 1 oxygen atom. Despite its scary-sounding name, dihydrogen monoxide is harmless. Indeed, it is essential to life. It highlights an important truth. The word chemical does not automatically mean something is dangerous or artificial. By understanding the composition and function of a substance, we can see its true nature rather than being misled by terminology. 3. Endogenous vs. exogenous chemicals. When discussing chemicals in the human body, scientists often differentiate between endogenous chemicals and exogenous chemicals. Endogenous chemicals are substances that the body naturally produces. For instance, neurotransmitters like dopamine and serotonin, hormones like insulin, and enzymes that catalyze reactions in our cells are all endogenous. These chemicals are synthesized internally and perform vital biological functions. Exogenous chemicals, on the other hand, come from outside the body. These include the vitamins we consume, medications, fluoride in toothpaste, and even the water we drink. Exogenous chemicals are absorbed, metabolized, and often integrated into the body's natural systems. This distinction is important because it shows that not all chemicals in our body originate internally. Some are ingested or absorbed from the environment, but they are no less crucial to life. 4. Water, and the human body. Water is perhaps the most fundamental chemical for human life. The human body is approximately 72% water, meaning that most of our cells, tissues, and organs contain water. This is true from the brain to the muscles, from blood to skin. Water serves as a solvent, a temperature regulator, a medium for chemical reactions, and a transport system for nutrients and waste. An interesting question arises: does the body make water? The answer is nuanced. The body does not synthesize water in the way it produces hormones or enzymes. Water primarily comes from external sources, the liquids we drink and the moisture in the food we eat. However, water is also produced in small amounts internally as a byproduct of metabolic reactions, particularly during the breakdown of carbohydrates, fats, and proteins. This metabolic water is not enough to meet daily needs, which is why we must drink fluids. So while water is not an endogenous chemical, in the same sense as hormones, it is still an integral chemical component of the body, without which life would be impossible. 5. Misconceptions about chemicals. Many people believe that the word chemical is synonymous with danger or artificiality. This is not scientifically accurate. Chemicals are neutral descriptors. They describe what a substance is made of. For example, oxygen O2 is a chemical. We breathe it every moment. Table sugar CHO is a chemical. We eat it daily. Water H2O or dihydrogen monoxide is a chemical. We drink it constantly. The confusion often arises from marketing, media, and cultural associations. Products labeled chemical-free are misleading. Everything is chemical at a molecular level. Even natural substances like vanilla extract, essential oils, and lemon juice are chemicals. The distinction lies in composition and function, not in natural versus artificial or good versus bad. 6. Chemicals and the origin of substances in the body. Another interesting aspect is how the chemicals we rely on enter our body. As mentioned earlier, some are synthesized internally, while others come externally. For example, fluoride in toothpaste is exogenous. The body does not produce it. Amino acids, the building blocks of proteins, are partly endogenous. The body synthesizes some and partly exogenous, must be consumed in diet, known as essential amino acids. Water comes mostly from external sources, although a tiny fraction is produced metabolically. This demonstrates that while our body is composed largely of chemicals, our survival depends on both what we produce and what we obtain from the environment. 7. Why this matters. Understanding that water is a chemical, that chemicals can be endogenous or exogenous, and that the term chemical is neutral has real-world implications. It helps in scientific literacy. People make better decisions when they understand what chemicals are and what they do. Health and nutrition. Knowing which chemicals are essential and where they come from informs diet, hydration, and supplementation. Risk assessment. Chemicals are often unfairly demonized. Understanding the science behind them reduces fear and misinformation. Environmental awareness. Recognizing that everything is made of chemicals encourages thoughtful consumption, recycling, and sustainability. 8. The water example in daily life. Let's take water again as a practical example. It is an exogenous chemical, meaning it comes from outside, but it is essential for life. Every day, humans must drink water to replace what is lost through sweat, urine, respiration, and digestion. Without water, cells shrink and fail to function. Enzymatic reactions slow down or stop. Blood volume drops, affecting circulation. Organs fail to operate efficiently. Yet, despite being external in origin, water becomes inseparable from our bodies. It illustrates a key point: the boundary between self-made and external chemicals is fluid in biology. 9. Revisiting dihydrogen monoxide. Returning to dihydrogen monoxide, the case demonstrates how misunderstanding terminology can lead to fear or confusion. Calling water by a chemical name makes it sound dangerous, but in reality, it is vital, safe, and universal. It also highlights the importance of context in chemical literacy. When people hear chemical, they should ask, what is the molecular composition? Is it naturally occurring or synthetic? What function does it serve? Water passes all these checks. H2O is natural, ubiquitous, and essential. 10. Key takeaways: all matter is chemical. Air, water, sugar, proteins, DNA, they are all chemicals. Chemicals are neutral descriptors. Chemical does not equal harmful. Endogenous vs. exogenous. Some chemicals are made inside the body. Others come from external sources. Water is a chemical. Dihydrogen monoxide is simply H2O. Your body is largely water, most of which comes from external intake. Scientific literacy matters. Understanding chemicals prevents misconceptions and promotes informed health and lifestyle decisions. By reframing our understanding of chemicals in this way, we see that our bodies, our environment, and our daily lives are interconnected through chemistry. Chemicals are not scary. They are the language of matter itself. 11. Final reflection: the confusion around chemicals often stems from terminology, media exaggeration, or fear of the unknown. By understanding that water, fluoride, amino acids, and oxygen are all chemicals, we can approach nutrition, hydration, and health rationally. Furthermore, the distinction between endogenous and exogenous chemicals is crucial. Our survival depends on both, what we synthesize internally and what we absorb externally. Water perfectly illustrates this principle: vital, universal, and often misunderstood when presented in scientific terms like dihydrogen monoxide. Ultimately, chemicals are not inherently dangerous. They are fundamental to life. The more we understand them, the more empowered we are to make informed decisions about our bodies, our environment, and our health.